All right, so we're going to continue on learning how to solve quadratics. First, we learned how to solve quadratics by factoring. Now we're going to move on and learn how to solve quadratics if they can't factor. And the cool thing about quadratics with the quadratic formula, which is what we're going to look at with this video, is that the quadratic formula works always. It works for problems where they could have been factored. It works for problems that can't be factored. It even works for problems where technically they don't have a real solution. So first, we're going to start off with the problem in standard form. So just like with factoring, you need to make the problem equal 0 before you get started. And then after that, you're going to figure out what your different coefficients are. So the coefficient for x squared we're going to label as a, the coefficient for x we're going to label as b, and then the constant, the plain number that doesn't have an x attached to it, is going to be c. So the quadratic formula is negative b plus or minus, and then the square root of b squared minus 4ac, all divided by 2a. And the part that's underneath the square root, this part right here, b squared minus 4ac, this part right here is called the discriminant. So that is the discriminant. And the discriminant is interesting because it tells us some important things about what our solutions are going to be. So if the discriminant equals 0, then when you solve the quadratic formula, you're going to have negative b plus or minus 0. The square root of 0 is just 0. So you would have negative b plus or minus 0 over 2a. And if that happens, instead of having two answers, one for the plus and one for the minus, you're only going to have one answer. So you're going to have one real root. One real answer, one real x-intercept. So the answers to the quadratic formula, the answers to the factoring problems, the answers to the quadratics, all of those show up on graphs as x-intercepts. And in this, we would only get one of those x-intercepts. So if you were to draw a picture, it might look something like this. You would have one real root, and that root would just be the vertex sitting on the graph. It could be below, but something like that. Okay? The next situation is we could have the discriminant, the number underneath the square root, could be less than 0. It could be a negative number. And if you guys recall from Math 2, if you square root a negative number, you get something that doesn't exist. So if you took, we'll do over here, remember, if you have the square root of negative 1, you turn that into a 1 with an I in the front. So anytime you take the square root of a negative, you take the negative, you make that positive, and you stick an I in the front. So the square root of negative 1 is actually just I. So if you had something like the square root of negative 4, you would say, okay, that's I times the square root of 4, and so that answer would just be 2I. Or if you had the square root of negative 7, you would say that's I times the square root of 7. So this is something that we learned in Math 2, and that is what would happen if you had a negative discriminant. So because there's a plus or minus here in the problem, you would have two answers, but they would be imaginary. We would have two imaginary complex roots. Two imaginary complex roots. And we say they're complex because the first part of this is real, the second part of this would be fake. And if you're real and fake at the same time, that makes you complex. All right, next we have what happens if the discriminant is bigger than 0? What happens if you're taking the square root of a positive number? Well, if you take the square root of a positive number, then you get an answer, and the answer you get is a real answer. And so we're going to say you get 2 real roots. Okay, so if your square root, if the number that you're going to square root is positive, you get 2 real roots. So we're going to draw pictures for these so we can see what they look like. If you get 2 imaginary roots, that means you're not going to have any answers. There's going to be no x-intercepts. So your picture might look something like that. And then over here, if you're going to have 2 x-intercepts, then your picture might look something like this, where it crosses the x-axis twice. So let me go ahead and zoom in on this so you guys can see those pictures. So this was the first situation. You have 1 real root, 2 imaginary roots. It doesn't cross the x-axis at all, so you have no x-intercepts, no roots. And then over here, 2 real roots. So these could be at nice whole numbers, or they could be at weird decimals. All right, so we're going to go ahead and go through some examples solving using the quadratic formula. Example number 1 might look a little bit familiar because what I did is I took the problem from the factoring notes and decided we could do it again and solve the same problem using the quadratic formula instead. So this is going to be a problem that's going to give us some nice answers. They won't be decimals because this is a problem that could be factored. So if we look at this, our A value is 10, our B value is negative 11, and our C value is negative 8. So if we start plugging numbers into the formula, first we have negative B, so negative of negative 11, plus minus the square root of B squared. Anytime I have a negative number that I'm squaring, I have to put it in parentheses because I want to make sure that my calculator knows to do negative 11 times negative 11. And so I need to make sure the negative goes in there too. Minus 4 times A times C, all divided by 2 times A. Okay, so what I always do first when I am plugging this into a calculator is I figure out what the discriminant is, because if you guys remember, when you take the square root of a negative, your calculator doesn't like that. So I'll just go ahead and show you. If I try to take the square root of negative 4, my calculator is not going to tell me 2i, even though I know that's what it is. My calculator is just going to tell me I have a non-real answer. I have a fake answer. So my calculator has a hard time with these. So if I wanted to find that, I'm going to have to do that by hand. All right, so what I'll do first is I'll just go ahead and I'll take this and plug it in and figure out what my discriminant is. So I've got negative 11 squared minus 4 times A times C. And when you plug that in, you can use the times button for your multiplication, or you can use parentheses for your multiplication. It doesn't make a difference. So let me zoom out so you can kind of get rid of that glare. And so you can see better. Okay, so I get the same answer for both of these. All right, okay. So, and then over here, minus minus makes a plus. So what I have here is 11 plus or minus the square root of 441 over 2 times 10 is 20. All right. So whenever you guys do this work, I want to see this written on your paper to see that you plugged all the numbers into the quadratic formula. And then next, I want to see this written on your paper that you plugged the numbers in for the discriminant and you wrote the discriminant down. Now at this point, I'm going to stop simplifying things. I'm just going to plug the whole thing into the calculator. Now, if this problem, if I had a negative here, I would kind of put my calculator away and I would finish this problem by hand. But if I don't have a negative here, then I can continue to work in the calculator. So we need to have a fraction in the calculator because this is written as a fraction. And the way you get a fraction in the calculator is you hit the green button, alpha, and then you hit the y equals button. And the fraction is the very first option. So we're going to get that. I need to type 11. Now the next thing in the formula is that plus minus, and there's not a plus minus button. It means that we have to do the problem twice. First for the plus, second for the minus. So I'm going to type a plus first. Next, I need to have the square root sign, and it's right above the x squared button. So it's in blue, so I'm going to hit the blue button, second x squared. Now I can see the square root sign, 441 over 20. So my first answer is 8/5. So x equals 8 over 5. And now I want to get the second answer. So what I'm going to do is I'm going to hit my up arrow and have it highlight the work that I plugged in here, and I'm going to press enter, and it's going to copy paste it for me. And now I'm going to hit the back arrow and put it on top of that plus sign and change that to a minus. So 8/5 and negative 1/2. Those are my two answers. All right, let's do it one more time. So here, we need the problem to equal 0 before we start. And so there's a form over here, so I'm just going to subtract that over to the other side. So now I've got 0 on the right side of the equation. So when I write these numbers out, I don't have any like terms, so I can't combine anything. That gives me 4m squared minus 4m plus 5 equals 0. So I've got my a value is 4, my b value is negative 4, and my c value is positive 5. So x equals negative of b plus or minus the b value squared minus 4 times a times c, all divided by 2a. Okay, so what I'm going to do next is I'm going to figure out what my discriminant is. Okay, so let's go ahead and type this in. We've got negative 4 squared minus 4 times 5. Okay, so my discriminant is a negative number, which means that I have to put my calculator away and finish this problem by hand. So I have x equals, minus minus makes a plus. So I have positive 4 plus or minus the square root of negative 64, all divided by 2 times 4 is 8. Okay. So now I'm going to say, okay, there's a negative here. I'm going to make this positive, and I'm going to make an I right there. So I know this is an imaginary answer. Now, if this number right here is not a perfect square, then you stop, you put a box around your answer, you are completely finished. This was a pretty easy problem. But if you have a problem like this, where 64 is a number that you can take the square root of, then you need to keep going. So if I look at this, I can see 64 is a perfect square. I can definitely take the square root of that. So I've got 4 plus or minus, the square root of 64 is 8. So 8i over 8. And then if I look at all three of these numbers, and I can divide out the same number from all of them, then I should do that. So 4, 8, and 8 are all divisible by 4. So 4 divided by 4 is 1, 8 divided by 4 is 2, 8 divided by 4 is 2. So the final answer here is 1 plus or minus 2i over 2. And that's my answer. And we are not going to finish the third problem. We're going to leave that for class so we can have an example to do.